Okay, so we're going to come back and we're going to explore what it means for triangles to be congruent and specifics about that. But basically, when we have two angles in two different triangles which are congruent to each other, the third angle must be congruent. What that means is, let's say we have this triangle, and let's say these two triangles are congruent, meaning all angles, all sides are the same. But more specifically, let's say that angle A is congruent to angle F. And let's say that angle C is equal to angle D. We don't need to know anything else to know that angle B must be congruent to angle E. That's called the third angle theorem. Now imagine A is 40 degrees and C, we'll say, is 60 degrees. That means that angle F is 40 degrees and D is 60 degrees. Well, that adds up to 100 degrees. So that leaves only 80 degrees left for angles B and E. So B must be 80, E must be 80, showing that they are congruent. This is really important because we don't need to say that three angles are congruent. We can just say that two of them are congruent, and it's assumed that the third must be congruent. This is called the third angle theorem. So this is going to be very important for us later on when we prove, but for right now, we are going to be figuring out the problems like this. So here we know that the angles inside of a triangle add up to 180 degrees. So we know that 62 plus 90 plus the measure of angle 1 is equal to 180 degrees. Well, this right here, this is 152 plus the measure of angle 1 is equal to 180. And that gives us that the measure of angle 1 is going to be equal to 28 degrees. So I can say, yeah, measure of angle 1 is equal to 28. Now for number 2 here, we have this symbol there. That means that this is also 30 degrees. So what we have is 30 plus the measure of angle 1 is equal to 180. So that means that the measure of angle 1 must be equal to 120 because 30 plus 30 is 60, and if we subtract 60 from both sides, we get 120. Looking at angle 3 here, we can see that we have, problem 3, we can see we need to find angle 1 and here. Well, it's going to be easier to find angle 1 first, so this is 90 degrees, so this is also 90 degrees. So we know that 60 plus 90 plus the measure of angle 1 is equal to 180. So the measure of angle 1 is equal to 180 minus this, which is 150, which is 30. And then we also have 30 degrees plus 90 degrees plus measure of angle 2 is equal to 180, and that's this lower triangle here. We know that measure of angle 2 is equal to 180 minus the 120, which is 60. Then finally, changing the colors here, we have this one. Now we know that measure of angle 1 is congruent to angle 2. So if we find angle 1 first, we can say 66 plus 58 plus the measure of angle 1 is equal to 180. We know that the measure of angle 1 is going to be 180 minus this piece here, which looks like it's going to be 124. And 180 minus 124 is going to be 56. So if measure of angle 1 is 56, I know measure of angle 2 is equal to measure of angle 1, which is 56. So I get that measure of angle 2 plus measure of angle 3 plus 50 is that second triangle here. Measure of angle 2 is 56, 56, plus measure of angle 3 plus 50 equals 180. Well, 50 plus 56 is 106, and so if I subtract that from 180, 180 minus 106 is 74. So this doesn't really seem like it's anything new, but just keeping in mind that triangles, the angles inside of a triangle add up to 180 degrees. That brings us to this. This is called the exterior angle theorem. This is another important piece. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Huh? Well, if we look at this picture, it's really simple to see. There are three interior angles here at x, y, and z. If we want to find this exterior angle here, remember that an exterior angle is made off of the supplement from the interior angle, so we just extend this line out, and we're talking about this exterior angle here. That's going to be equal to the sum of x plus y. These are called those remote interior angles because they're the interior angles that aren't touching this exterior angle. So if I add these two measures together, x plus y, it's going to be equal to this. And we can work this out as a proof, but if you think about it, these two angles plus this interior angle here equal 180. So that means that, well, if these three equal 180, and then this exterior angle plus this interior angle equal 180, then that means that the exterior angle and that interior angle must be the same. So here, yet again, we know that measure of angle 1 is going to be equal to the measure of angle 2 plus the measure of angle 3. So don't focus too much on the words, but definitely know the pattern, know what this looks like. This is really helpful for us for solving questions like this. So we want to find the measures of angle 1, 2, and 3, and 4 and 5. Well, if I wanted to find angle 1, you can think about it this way. You could just find out this remaining interior angle and just subtract that from 180 to get angle 1. But that's two steps. We can solve for measure of angle 1 in one step. The measure of angle 1 is equal to 50 plus 78. That's that exterior angle theorem. So the measure of angle 1 is equal to 128. Likewise, measure of angle 2, so measure of angle 1 plus measure of angle 2, these are a linear pair, so they are supplementary. So if 128 is the measure of angle 1, measure of angle 2 is equal to 180 minus 28, which is going to be 52. Now, I can actually use the exterior angle theorem again. This is where it really helps writing these equations like I am. We've done this before this year, and so this is another great case. I know that the measure of angle 2 plus the measure of angle 3 is equal to 120. Notice these two interior angles add up to get the opposite exterior angle. Measure of angle 2, I already know, is 52. So that means that 52 plus the measure of angle 3 is equal to 120. So that means that the measure of angle 3 is equal to 120 minus 52, which is going to be 68 degrees. And then using a similar method, we know that the measure of angle 4 plus 120, that exterior angle there, equal 180 because they make a linear pair. So that means that the measure of angle 4 must be equal to 60. And I can set up another exterior angle equation saying the measure of angle 4 plus 56 is equal to the measure of angle 5. Measure of angle 4 I know is 60, so 60 plus 56 is equal to the measure of angle 5. So the measure of angle 5 must equal 116. This is a quick approach to solving this problem. Notice I didn't solve for really anything extra. All I did was use the exterior angle theorem and looked at a linear pair for supplementary angles. That's it. This is really nice and straightforward. Now, if you wanted to, you could find out, this blank angle, this blank angle, this blank angle, and then use your rule about 180 degrees inside of triangles. But that's time. That's extra work. And sometimes that can be a lot. So if you just focus on this exterior angle theorem, it saves you time and helps you find these answers. All right, so we can do the same thing with these problems here. So the measure of angle 1 is going to be equal to 50 plus 65. So the measure of angle 1 is equal to 115. Over here, we saw this a bunch of different ways, but let's just say that measure of angle 2 plus 25 plus 35 is equal to 180. That means that the measure of angle 2 is equal to, this is going to be 60, so 120. And actually, I can also say that the measure of angle 1 is equal to 25 plus 35. So the measure of angle 1 is equal to 60. And notice measure of angle 1 and measure of angle 2 are a linear pair. They're supplementary. All right, so right here, this is looking like it is a tricky one, but we have parallel lines. So what happens when we have parallel lines? Well, if I have this parallel line and that parallel line, this is my transversal. If this is 60 degrees, measure of angle 1 is 60 degrees. And if that's 60 degrees, so yeah, measure of angle 1 is 60 degrees. So if measure of angle 1 is 60 degrees, that means, here we go, parallel lines there, and we also have these two lines as parallel lines. So if we look at this as the transversal, there we go, that's 60 degrees. So measure of angle 2 is equal to 60 degrees. Measure of angle 3 is going to be 60 plus 60. So the measure of angle 3 is equal to 120 degrees. That exterior angle theorem at work for us. All right, number 4 here. I can get angle 1 easily by saying measure of angle 1 plus 36 plus 35 is equal to 180. So the measure of angle 1 is equal to, here this is going to be 71. So measure of angle 1 is 109. Well, the measure of angle 1 plus the measure of angle 3 equals 180. So 109 plus measure of angle 3 equals 180. So the measure of angle 3 is equal to 71. Oh, and look, we could have used our exterior angle theorem for that too. 35 plus 35 plus 36 is 71, which is angle 3. And then if I say measure of angle 2 plus 80 is equal to the measure of angle 1, which is 109, I get that the measure of angle 2 is equal to 29. Going down here, we have a little bit of algebra, but we set up an equation and we say that 2x plus 95 is equal to 145. Subtracting 95 from both sides, we get that 2x is equal to 50. So x must be equal to 25. And let's go back to orange for this last problem here. And we can say that x plus x is equal to 58. Well, that's just 2x is equal to 58. So x is half of that, which is 29. So those are those questions using the exterior angle theorem. It's a quick way, it's a quick approach to solving these. But as you notice, the pattern with these is if you want to solve them, it's very important you set up an equation first, solve that equation using the relationship. So two important theorems today, the exterior angle theorem and also the third angle theorem. Make sure you realize them both, are familiar with them both, because they will both be important for when we start proving congruence of triangles.